All right, hi everyone. I'm Joey Echeverria. I'm currently Cloudera's chief architect for public sector, but I'm actually transitioning to our product development organization soon to work on our software development kit, which is called Kite. This is a talk on security. If you went to Matt Brandwine's talk yesterday about the EDH, which was actually also a talk about security, I apologize. They stole my title without out asking me. So this is not the same exact talk, mostly because I just make up my own stuff. But it is also on security, so sorry if you wanted a talk on data management. But it's not really a talk on security, because security is really, really boring. In fact, just yesterday, somebody tweeted how all the talk at this conference was about security, and security is the next big differentiator and buzzword for Hadoop, and quite frankly, security is just boring. So I'm actually going to talk about Hungry Hungry Hippos. So if you haven't played it before, Hungry Hungry Hippos is just a wild and crazy game where you're maniacally hitting a plastic hippo, trying to get it to eat all of the marbles before anyone else can eat the marbles. And typically, the way this game is played is you all have just one color of marbles. The default is white. But white is pretty boring, and because I'm the one giving the presentation, I'm going to change the rules. So in this version of Hungry Hungry Hippos, we're actually going to use multicolored marbles. And again, there's no real reason to use multicolored marbles, except that I felt like it, and you all have to listen to me for the next 40 minutes, so you're kind of stuck. The cool thing about multiple colors of marbles, though, is that we can also adjust the rules to say that your goal is not to get the most of any kind of marble. It's to get the most of a specific color of marble. But if we do that, we want to make sure that we actually restrict which marbles you're accessing. Not all marbles should be available for every user, and for good reason. Do you really want these yahoos just accessing all of the marbles willy-nilly? I mean, look at that guy in the green. I do not trust men with beards. Just flat out, don't do it. It's not a good idea. So we really got to put some controls in here. So the first way we could do this is we could pre-sort all of the marbles. So because this is a PowerPoint presentation, I can just make up magic on the fly. So not only are we going to pre-sort the marbles, we're actually going to put them in these magic boxes such that each hippo can only access its own color. So if it tries to eat the marbles in another box, it just gets denied. If it goes for its own box, it magically passes through, eats the marbles, no problem. That's a very great solution, but it's kind of coarse grain. I have to pre-sort all of the marbles, and I don't really want to do that. So if a little bit of magic is good, a lot of magic is even better. So instead of having to pre-sort the marbles and put them in magic boxes, let's just use magic marbles. So now imagine that these marbles are set up so that each hippo can only access a specific color of marble. Now I don't have to do anything. I can just throw a handful of marbles onto the board, everyone can start playing and have a grand old time. The other nice thing is that I can invite more people to play the game. I can just add more and more hippos, more and more different colors of marbles, and because of magic, everything works. And this is pretty much the way that security works. The other advantage is that I'm very, very lazy. I don't want to have to think about how do I set up the perfect access controls to everything in a system. I just want there to be a lot of magic that takes care of it for me. I already colored the marbles. Why should I have to do anything else? So by now, you're probably like, what on earth is he talking about? Why am I talking about Hungry Hungry Hippos? Does any of this have anything to do with Hadoop? And the answer is yes, because I'm the one giving the talk. And like I said, I get to control the agenda. What it really has to do with Hadoop is the way that people have adopted Hadoop over time. When Hadoop was first used, it was kind of like that original game of Hungry Hungry Hippos. All of the data was basically open to all of the players. You trusted everyone that you invited to your Hadoop cluster because really you only trusted 2 guys to even use Hadoop, so obviously they could access all the data. But anything that's useful tends to gain adoption, and that's what's happened with Hadoop. Hadoop is a useful enough tool that we want to invite more and more players to the game. We want more and more people accessing more and more different types of data, and that makes things more difficult. In particular, you have to start thinking about how do I control access to data. The way that Hadoop originally started this was with basically advisory file permissions. You could set permissions on all of your objects, but you didn't actually control the authentication. So you could go in and say that only Bob can access this file, but anyone on the system could claim that they were Bob. That's not particularly useful if you care about malicious users. If you're just trying to stop people from making mistakes, it works great. So the way that Hadoop solved that is they added Kerberos. And I'm sure that all of you have heard about Kerberos. And the reason why I'm sure you have is because when anyone talks about Hadoop security, 90% of the time they mean Kerberos. I went up and set up Hadoop security on a cluster last week. Really, it means that I turned on Kerberos. That's really great. It solves a very important problem. But it's not necessarily ideal because Kerberos is a little bit hard to set up. On the plus side is I now know that you are the cute little baby and actually should be accessing the files that you've been granted and not some malicious user that's trying to get at something that you're not supposed to have. But you still have a problem with the size of the objects that you're accessing. Before I get into more on the granularity of data in Hadoop and use the analogy of how that corresponds to the different marbles, I want to talk very quickly about isolation. One of the ways that MapReduce in particular implemented security is it strongly isolates all of the processes that run your MapReduce tasks. The reason why this is important is that before Hadoop had security, all of the processes on the cluster basically ran as the same user. So regardless of what kind of security controls you put into the system, you were always running as the same process, which means that you could always sort of look over your shoulder or peel behind the curtain and see what other users were doing. When adding a strong authentication, you also need to have process-level isolation. You want to make sure that anyone that's running a job on the cluster can only access the files that are part of their currently running job. And the way that this is done is each task is actually run as the user that submitted it, in the sense of it's a Linux process with the user ID that submitted it. The reason why I bring this up is that this is something that people don't often get told or don't get told enough. And it means that they have to go through a lot of pain when setting up their Hadoop cluster because they set up all this fancy security stuff. They try to run their jobs, and suddenly they just say, oh, yeah, I don't know who that user is. And you're like, of course you know who that user is. I created it in Kerberos. The user's right there, except he's not. The user has to exist on every node in the cluster, not just in Kerberos. The nice thing is that it's not actually that hard to do on a cluster of Linux boxes. You can use LDAP or Active Directory, and it'll actually handle most of that for you. But it's just something to keep in mind if you're doing any kind of secure Hadoop deployments. The reason why Hadoop is so hard to secure is because it's fundamentally a system designed to let you execute arbitrary code over arbitrary data. You say that one more time. You execute arbitrary code over arbitrary data. By default, it's designed to be wildly insecure. It's just like, just write some code, send it to me, and I'll just run it. I trust you, dude. It's cool. Makes it very, very difficult. So that means that in order to actually start layering security onto such a system, you have to put security controls at basically every level of the stack. So by this point, you're probably like, God, this is depressing. Security is so complicated. I have to implement all this stuff. I have to do all the system administration. Why am I even bothering with security? It was great when I just had the 2 guys on the Hadoop cluster and no one else used it. They got all the resources. They never had to contend for sharing. So why are we even bothering to do this? And it all comes back to sharing data and sharing resources. Hadoop is a wildly useful tool, and any wildly useful tool will gain adoption. And you don't want to gain adoption by having to buy a Hadoop cluster for everybody in your company. You probably have hundreds or thousands of employees. Buying a Hadoop cluster for everybody is going to get very expensive very quickly, especially since they're not going to always be using all of the Hadoop all of the time. What you really want are large multi-tenant clusters. A 100-node Hadoop cluster that's used for a particular group in your company is awesome. What's even cooler is a 1,000-node Hadoop cluster that's shared by all of the people in your company. So the first way that people started to handle this problem of multi-tenancy was a project started at the National Security Agency called Apache Accumulo. And Accumulo is based on a Google paper called Bigtable. that was released, I want to say, in 2006. I would ask for a fact check, but none of you have microphones. And one of the ways that Accumulo deviated from the original big table paper is it added the ability to label data with security labels as it was entered. So that meant that every single piece of data that entered the system was labeled at the cell level. This was about as granular as you could get. Every single cell of data could have a different security label, and all of the labels were enforced whenever you tried to access anything. This is great, but the downside is that the big table design and the Accumulo and HBase implementations were never really designed for large batch scans or full table scans. They were really designed for point lookups or relatively shorter range scans. But it turns out that there's actually already a system in the Hadoop world that is designed for large batch scans, hint, it's MapReduce. And there's a file system that's implemented that is great at scanning large volumes of data. It's HDFS. So why do I even need to layer this other system on top? And it all comes back down to granularity. At HDFS, you could only control data at the file and directory level. You couldn't actually set up permissions so that individual records within a file got protected differently than any other, or individual columns in your data were protected differently than the entire file. And this goes back to the analogy of the Hippos game. You had to pre-sort all of your data into large files that represent your security boundaries before you can give access to it. So now your security policies are dictating the way that you have to lay the data out on your system and dictating the way that you have to do your data processing and analysis. And that's just not cool. But the community actually rallied behind this idea and started to implement a solution called Apache Century. And so the way that Sentry works is it actually plugs into the various processing engines that are out there. Today it works with Hive, Impala, and Solar. And it lets you do security at the table level. You can actually sort of squint your eyes a little bit and get column level security, because you can also set security on views. And you can set views that will filter specific columns out before they present it to a user. So this gives you the flexibility and granularity that you need to start doing much more interesting things. The downside is that Sentry only works with a subset of the Hadoop ecosystem, and you can't really share data securely between, say, Hive and MapReduce proper or Pig. So another way that people have approached security is by looking at it from the perimeter. Instead of trying to bake all these fancy security controls everywhere in the cluster, let me just secure the front door and have a gateway that handles all of the access from outside. And the most popular perimeter security tool available today is probably Apache Knox. If you think about perimeter security, it really started with the introduction of Hue, which was much earlier. The difference is that Hue focused on giving end users a nice user interface for accessing a Hadoop cluster, which meant that the level of access was always at a human being. Knox, on the other hand, gives you REST APIs and proxies so that you can actually have machines talk to your Hadoop cluster from outside and get all the security goodness. The only downside to Knox is that not all of the REST APIs are drop-in compatible with the equivalent Hadoop interfaces, which means that if you adopt Knox, you also have to adopt some new clients if you're running existing Hadoop stuff. The other downside is that if you're going to allow people to execute jobs on the cluster, you still have to implement the rest of Hadoop security. You know, I talked about that process level isolation that exists in MapReduce. You really need that running to prevent people from just sort of getting initially through the front door and then running amok once they're on the inside. A big part of this all comes down to trust. Now, you can all trust me because I have the microphone, and I've got this shirt that says you can trust me. But not everybody trusts everybody else in their organization. In particular, if you're implementing a large Hadoop cluster, you have to trust your system administrators. Because if you have root access to the nodes of a Hadoop cluster, you have access to everything. You also have to trust your network administrators, because if you have the equivalent of root access to your network, you can sniff all of the traffic on your cluster, and you can just see what everybody's talking about and all the data that's passing around. For small organizations or even large organizations, that may not be a problem. Your trust model and your security and threat model may be such that you can trust your administrators and it's not a big deal, but not everybody operates that way. So the solution when you don't trust everybody is to start adding encryption. In the first place where the Hadoop ecosystem added encryption is actually over the wire. We trusted the network administrators far less than we trusted anyone else. Anyone here a network administrator? All right, good. I'm not offending you. So with Hadoop today, you can encrypt the RPC traffic. So that's all of the sort of the metadata and instructions going from clients to servers and between servers. You can encrypt the actual data as it's streaming into HDFS or streaming out of HDFS. And you can encrypt the shuffle data when you're running a MapReduce job. So as the data moves from the mappers to the reducers, all of that can be encrypted. One of the downsides is that because developers are lazy, most of the Hadoop interfaces use SASL for encryption because it's the same interface that they used for authentication. And that was used because it doesn't require you to build the authentication into your protocol, but actually lets you layer it on after the fact. And that was also used because it works natively with Kerberos, which is the basis for all authentication in Hadoop. But what's lacking is encryption at rest. So you've secured your network. You no longer need to trust your network administrators, but now you have all these root users that are going in and just accessing blocks willy-nilly. They're stealing data. You don't know what's going on. So what Hadoop is working on today is getting native encryption built in for data at rest. Historically, you've been able to use tools like Gazang to do encryption after the fact, but that hasn't been built into Hadoop itself. It all happens on the actual volumes and on the disks. What's going on right now will actually build it into Hadoop and let you do encryption at the block layer. The other cool thing is that you can specify which data sets need to be encrypted. You don't need to encrypt your entire file system. And for a lot of users, they don't care about the entire file system. They only care about certain data sets. And with the work that's going on upstream right now, you'll be able to do that. But what's really cool is that all of the work is being done such that it has pluggable interfaces. You don't have to use the one key management system to rule them all. And that's really good because the one key management system to rule them all probably hasn't been blessed by your security officers. It probably hasn't gone through your procurement process. And it probably goes against the standards that you already have in place. So that pluggability is very, very key. The other really cool thing is that all of this is being built on top of the native AES instruction sets available on Intel processors. So that means that you're getting hardware-accelerated encryption for all of your data, or all of the data that you want to have encrypted. So that means that you can have this encryption without having to pay a big penalty, a big performance overhead, which means that you're getting scalable, high-performance encryption across all of the data in your cluster. Yes. So by this point, you're probably saying, when are you going to talk about the future? That was sort of the title of your presentation. Fortunately, I have this crystal ball available, so I will now tell you what the future of Hadoop security is. And I know it's the future because the future never actually gets here. It's always there, which means that I can never be wrong. If you watch what we've talked about, you can sort of already see some themes developing. And the first theme is that more and more users are getting access to Hadoop clusters. More and more users are signing on to these systems. The other thing that you're seeing is that these users need access at lower and lower granularity. You want to be able to fine-tune the control of data at individual levels. And then the last thing that you'll see is that we don't trust all of our administrators anymore, so we're adding more and more encryption capabilities. And then finally, as more users are coming together and as the granularity of data access is becoming lower, you're increasing the size of your clusters and increasing the amount of data that you're processing, which means that you have to do all of the security stuff but make it scalable. So again, that brings us to granularity. Sentry was a great first step towards improving the granularity of data access on HDFS. But if you look at Accumulo, so Accumulo has cell-level security. Cell-level security was so much fun. Those developers and users loved it so much that the HBase community copied them. They added cell-level security in HBase 98 because they were tired of not being invited to any of the cell-level security parties. So an open question is HDFS next? Can we actually implement cell-level security in HDFS? And I'd love to tell you that, yes, we're doing it, and it'll be announced tomorrow. But unfortunately, it's harder than that. It's very difficult for a system to try to secure objects that are lower than the objects that it natively tracks. And HDFS tracks files. It doesn't track records inside of files. But fortunately, Sentry is coming to the rescue. Sentry is starting to already add more processing engines. When it first got released, it only supported Hive and Impala. Solar was added not too long after that. It's working on figuring out how to add support for MapReduce, Pig, Spark, all of these other great processing engines that are out there. And on top of that, they're also working to improve the manageability of it. If you've ever used Sentry, you know that it's great technology. It does great things for security, but it's awful to use because you have to write this archaic configuration file that makes no sense to anybody. I'm pretty sure not even the developers that originally wrote it. But that's actually being fixed. So you can already go and download newer versions of Sentry, and they've replaced that configuration file with a database, which is where it should have been to begin with. And they've implemented grant and revoke SQL syntax so that directly from Hive or Impala, you can just control roles, you can assign users to roles or groups to roles, and you can assign permissions to all of the different objects and tables that you have in your cluster. But what's really cool is the way that Sentry is approaching the problem of how do I control access to objects that are smaller than the file level? And on top of that, how do I integrate all of these processing engines without having to implement a plugin for every new engine? I don't want to have to write the Sentry MapReduce plugin. I don't want to have to write the Sentry Pig plugin. I don't want to have to write the Sentry Spark plugin. I really want to get to a point where I can start accessing records on a Hadoop cluster through a central service. So what's being talked about, and this is still in the design phase, so things may change. But again, since I'm talking about the future, eventually everything that I talk about will be implemented because the future's not here yet. We're designing something called the Sentry Record Service. And the way the Sentry Record Service will work is a distributed service that runs on your cluster, and it provides access to the underlying files. So now, instead of all those processing engines talking to a file system, which is kind of silly for processing engines that are largely built for processing records anyway, they're going to talk to a service which presents records to them. Those records will be stored as files in HDFS, but you'll be going through Sentry in order to get access to them. And if you do this with a distributed service, it gives you all sorts of great abilities to do things like cache records that are accessed very frequently, and also to layer in capabilities. So you could imagine layering in not just the record filtering service that Sentry is going to do based on the permissions associated with the data, but also filter out or actually do native encryption and decryption of data as you access it. So now not only are you getting fine-grained access to data, you're enforcing that fine-grained access through encryption. Another key initiative that's been worked on in the Hadoop ecosystem recently is called Project Rhino. And really, that's a blanket term started by Intel to cover a lot of the new encryption features that are being added. And the thing that I love about Project Rhino is that it's all about adding encryption interfaces deep into the system so that you can access it from everywhere else. The other cool thing is that it's all pluggable. You'll be able to plug in new key management systems. You'll be able to plug in new encryption and decryption algorithms. And the ones that are being built natively all take advantage of the instructions on Intel CPUs so that any encryption you do is going to be blazingly fast. Because the last thing that you want to do is add a bunch of security that now makes your Hadoop cluster twice as slow, which means that you have to buy twice as many nodes. It just becomes much more expensive. So in sort of wrapping up my talk, I want to go back to the idea of sharing. The whole purpose of deploying Hadoop systems is to actually share more data and to share data with more users. And the core of being able to do this at scale and to do this across an entire organization is to add security. So while security is very, very boring, what security enables is ridiculously cool. The ability for all of your users to share in all of your data and to access it using the methods that make the most sense for their specific use case and their specific problem. So in closing, you should go out, implement some security, and have some fun. With that, I have lots of time for questions. Yes?
Hi, Joy. Nice session. I needed to ask you about the scoop thing. When people also have this use case where they do the processing, the user has the rights, do the security, and they have encrypted the thing, they have done some aggregation, grouping, and then they're scooping it out to an Oracle instance or something like that.
Yes.
I was wondering whether you should have it at the scoop layer as well. Whenever the data goes out, it should be encrypted, and then at the Oracle level also you should have that same functionality of, so that the same user only, so encryption key or decryption key, if you are giving that out, or even the hashing thing, right, or the masking, do you have only the encryption, decryption, or you even have the masking? So these are two different questions.
OK, so there are two questions there. The first one is a common use case is to use Scoop2 to share data between your Hadoop cluster and databases. So you want to make sure that the security controls are implemented at that level. And ideally, you want to make sure that if you have data that's secure on Hadoop, that the same security policies are applied in, say, Oracle.
Yeah.
So that's absolutely a great use case. One of the great things about the work that's going to be done in Sentry to support MapReduce is that Scoop will be supported through that natively.
Right.
So there won't have to be a special integration done there. To do the reverse integration where you're sort of enforcing security controls from Hadoop into your Oracle system.
Which can be taken by the operating guys who
Yes.
can create the same user. Yeah.
Exactly.
So if it is in the Scoop layer, that should be more than sufficient. Yeah.
Yep.
Yeah.
And then your second question was on data
Hashing.
masking.
Yeah.
Yeah. So there's a lot of great third-party companies out there that do data masking, and they can plug into Scoop and Flume and all of the other popular ways of getting data in. The one that I'm familiar with is called Data Guys. So they can actually apply masks in two places. If you have a set of data that's already in Hadoop, it can process all of that in batch and then rewrite it with the proper data masked out. Or you can actually put the data masking into your ingest pipeline so it's masked before it ever gets there.
All right. Yeah. Thank you.
Thanks.
Hi.
Hi.
I had one question. So when we talk about encryption, we also need to talk about the keys that is used for the encryption. So what is the story with respect to key management?
Sure. So the question's about encrypted key management. And that's really one of the areas where Cloudera is why Cloudera purchased Gazang, because Gazang has a system that does secure key management. And the way that the ecosystem is moving forward is that all of the encryption features that are being built into the platform, built into Hadoop itself, don't do the key management directly. They have APIs for key management, and that allows them to plug in key management servers that have already gone through certification processes. So that way you'll be able to go with Gazang, or if Gazang's not your favorite, you can go with another vendor, and you can use their already certified key management system on top of the encryption capabilities being added to the platform.
One related question is basically, when we are saying that the records will be actually provided by the service, the Sentry record service, what happens to locality?
What does that look like?
What happens to locality issue? So
What happens to locality? So it's actually not that difficult to maintain locality in that case. What would happen is that the way that your data gets split when it's presented to the processing engine will be determined by the Sentry record service, but the Sentry record service knows where all the data is in HDFS. So we can use the same tricks to ask the name node, all right, where are these blocks located? And then it can assign that set of records to be read by the Sentry record server that's local to the data node that hosts the data.
Quick question. Maybe I missed it. You keep talking about record server, but is there a cell level security in that record server?
So the record server itself will just interpret the common file formats in Hadoop and then present those records up to the processing engine. And then Sentry's policies will be applied to that data. So today, Sentry's policies are limited to the table and view level. But in the future, you could extend those policies in that policy language down to the record level. The way that that would probably work is that you would have particular fields in your records that represented the security for a cell. And then as users access data through the Sentry record service, you could look up in LDAP or some other directory service what labels they have the permission to access. And then that same filtering and enforcement could be done on the per record level as is done today on the table and column level. You could go down to cell as well. The way to do that is that you just have to decorate individual fields within a record. You still have to label the data, yeah. It's very difficult to try to implement cell-level security purely from the outside because basically anything you do has to label all the cells, which means that you basically end up creating two systems that all have an exact duplicate of your data. It's better off to merge those labels into the records and cells themselves, where they live and where they're stored, and then do that filtering at read time. Another question?
Yeah. While not security challenge, we had a very similar challenge back in the day where we added all these different data formats, and we have all these different ways of process files like Hive, Pig, or what have you.
Yep.
So we implemented something called HCatalog. That's a layer that allows us to reuse the ways of reading the files. So is this kind of like the security implementation of something like HCatalog for security purposes in terms of pattern? And
Sure.
Is it going to be integrated with HCatalog, or are you going to store this data somewhere else?
Sure. So the question is, how does this relate to HCatalog? And the answer is that we're actually going to be doing all of the integration through HCatalog. So HCatalog is going to become the interface to the Sentry record service, because that's also the interface to the metadata. So that way you'll be able to get security through all of the objects that are already managed by the HCatalog service.
What are the performance penalties you feel by adding more security on that?
So the question is about performance penalties on security. It really depends on the specific security that you're implementing. So just for example, if you turn on the encryption over the wire features that are available today in Hadoop, and you run a Terra sort before and after doing that, you end up paying about a total of a 10% penalty, assuming that you're using RC4. That's not terrible, but it's not great. That's part of the big push to implement the encryption features using AES. As far as security or performance overhead, when you talk about implementing data filtering at either the cell level or column level or however you're doing it, it turns out in practice that actually doesn't add very much overhead. There is some storage overhead if you're doing cell level security, and that increases the amount of I/O you have to do. But in terms of actual performance, it's not that big of a deal because it's the equivalent of just adding a predicate to your SQL query. So you already have to implement filters as part of your data analysis, so implementing filtering for the security doesn't add too much. Any other questions?
Yeah. So one thing that I've been playing with Sentry right now a lot, and the one thing, the policy file, I'm not a big fan of, but on the other hand, I also know that it's securely put away in the HDFS file system. I know in talking with your product manager yesterday, we've also been doing some talking on our side, looking at this thing. The one thing is once you put it into a policy database, now how will you secure the policy database? What's going to be, how far do we take this at this point?
Sure.
Because that's the High 13 problem right now as well with grants.
Right. So the question is how you secure the actual policy database that your policies are stored in. And right now we don't have a good story there. The basic assumption is that you already know how to secure a database running in your data center. And so you'll implement the same security controls that you would use for any other database-backed application and limit access to the policy data only to Sentry.
So I have a question. So I was looking at Apache Sentry. So I understand, as far as I could find out, that it works with Hive Server 2.
Yes.
So that means if somebody goes to Hive Shell and they don't use Hive Server 2, can they still bypass all the things that have been configured in Sentry?
Sure, sure. So today, that's true. You end up bypassing Sentry if you're accessing it through Hive or through the Hive CLI and not through the Beeline command line client. One of the side effects of the new features that we're working on to enhance Sentry and to make Sentry work with MapReduce, Pig, and everything else is that hole will actually be plugged. And the way that we're doing that is when you implement security controls in Sentry, not only will Sentry do the security policies themselves, but it'll actually push those policies down to the underlying files in HDFS, taking advantage of the new access control lists that are available in Hadoop 2.4. So you'll be able to plug that hole. We recommend that people move to Beeline. We know that there's some holes and gaps that still need to be solved. But long-term, Beeline's going through Hive Server 2 is going to be your best bet. But in the meantime, while we're waiting for Beeline to catch up, you'll be able to start using the Hive CLI and still get Sentry protection. Yeah. So the question's about how does this relate to what's happening on the Apache Hadoop side? For which part of security? So yeah, so I think the question is that there's some big tickets in upstream Apache Hadoop for implementing new security features. Everything that I'm talking about, it's the same work. Yeah, so this is not stuff that we're doing unique to Cloudera. This is all stuff that's happening upstream, either in Hadoop proper, especially in the case of things like Project Rhino, or in Apache Century in the case of the filtering of data at a more granular level. Yeah, everything's getting merged upstream. That's the way that we always implement platform features.
Hi, how can one describe like security labels or things for records of a piece of arbitrary data that's going into HDFS that will be, labels for how it's accessed, but when it's written, like how can it know about that kind of construct ahead of time?
Right. So the question is, how do you know how to label the data as it's coming in? And the answer is that, unfortunately, there's not a magic solution for that. Most organizations that need cell-level security, they already have rigorous labeling regimes. And so those regimes already get applied to data, and so they're just pulling those labels out of the data as it comes in. In general, if you wanted to add some kind of label security scheme, the way that you would do it is you would have to identify one or more fields of your data that can let you infer how that data needs to be protected. And then you would process that data as it filtered into the system and then apply the right label to it when you stored it. Any other questions? All right, thank you very much.